Thank you very much for this assessment of the consequences of climate change. I'm sure there are many. Yeah, please.
I think that you use this or this if you want, so that you gave a sort of explanation for why the 2 degrees are significant. But many people question that the number. Why 2 degrees and not 1.5 or 1 degree? What you show going up to 3 or 4 degrees is really huge. I read the other day that in the Ice Age in Europe, the world was not cooler than 4 or 5 degrees than it is now, so it's really dramatic. But why the 2 degrees number?
I'll try to elaborate. First of all, if you go back in time, geological stories are quite expensive. So, by the way, this also answers partly the question of things have changed in the past. Yes, but science tells us why. So we know why the ice ages were there, because changes in the orbital parameters of the planet and so on. And so those were huge temperature changes, very significant for people had to survive in the ice ages. But current civilization, in the last 10,000 years, the climate has been very steady, okay, and that has helped a lot. But going back to the 2 degrees, it's just a consensus of scientists working with economists for something that is achievable at a very reasonable cost. That's all. There is a risk that even at 2 degrees you will get some of these nonlinear effects. But the risk increases very rapidly for these nonlinearities if you go above 2 degrees. That's one of the difficult parts of modeling because of the complexity of the climate, to predict these nonlinearities. But again, it's really arbitrary, but feasible. 1.5, I was just part of a study we did in California, but with a global mix of experts, suggesting that 1.5 degrees was also feasible, and that was discussed in Paris. After the US election, I suggested, and they heard me, let's not label the study 1.5 degrees, because given these changes, we would be happy even with 2 degrees, okay, with the election changes. So it's just something in practice. What can be done with a reasonable cost on emissions, but there's no sharp line, and it all has to do with risks and probabilities. By the way, I should clarify also, this is an interesting point. You can talk about risks when you can estimate probabilities. There are other issues, difficult ones like the nonlinearities, where you just talk about uncertainties and you cannot talk about probabilities, and the risk is not quantifiable. Some of the measures we were talking about yesterday, going to other planets in space and so on, that's, you know so little about that, you have to guess. Here you can do a lot of modeling, but it's arbitrary.
Thank you for this fantastic, brilliant paper. I want to ask, of course, I know it's a question complicated, but some people say that not only have the climatic change influence in the situation of desertic or raining, but also in the terremotos in Spanish,
earthquakes?
Yeah, exactly. Mm-hmm. And because they say it's impossible that the atmosphere not have some influence in the plaques of the land. But I don't know, but it's clear that in Rome there are many autarkies that we can give a special explanation.
Okay. Yeah, let me see if I understood correctly. Of course, the impacts of climate change are multiple. We're worried about the impacts on society, but I should have mentioned, of course, there are very worrisome impacts on biodiversity as well. And as you all know, again, the main cause is burning fossil fuels, but deforestation is another very significant source. But deforestation sometimes actually in some parts of the planet help the other way around. But just for the biodiversity question, that just means we have to have a more open perspective, not just climate change, but sustainability in very general terms. And by the way, I should have expressed sustainability's worries about future generations. So that's why it would be highly responsible towards future generations to allow this 1 in 5 possibility, okay? But earthquakes, okay? There are some earthquakes that are caused by fracking, perhaps, the extraction of gas with methane, particularly natural gas, with these new techniques. If you do it correctly, that can be sort of minimized. But the normal big earthquakes that we know about, those are, we believe, not connected with climate change itself. They have to do with movements of the Earth's crust and so on. Those are just additional examples of disasters. Those are indeed natural disasters. I worry when we talk about these huge hurricanes as natural disasters as well. They are sort of natural, but they are caused by human activities with a significant probability. So yes, society should be able to respond, but particularly after you identify some human activities that are responsible for that. And as you know, I should have given the example. We do have one successful example of a global issue that was dealt by society, all countries of the planet put together, and that's the stratospheric ozone issue, ozone depletion, through the Montreal Protocol. We have one example that it works. It can be done. The ozone layer is on its path to recovery, and so that we're very proud of having succeeded, at least with that example. But with earthquakes, I'm afraid the only thing you can do with science, which is terribly important, is to try to predict them. But that's very hard. Yeah.
Thank you, Theodore. With respect to the increasing levels of CO2 in the atmosphere here.
Oh, there, sorry,
yeah.
Okay.
With respect to the increasing levels of CO2 in the atmosphere, I wonder if there are scientific studies to determine to what extent that is also due to the fact that we are affecting the photosynthetic biota by contaminating the oceans and deforestation and so on. So would there be ways to counteract this problem by intervening into the photosynthetic systems on Earth?
Yes, I think that's reasonably well understood because the natural balance had been working for hundreds of thousands, if not millions of years, okay? That's photosynthesis, of course, converts CO2 and water vapor to hydrocarbons and to food, okay? And when we burn food, we release the CO2. So there are some changes because of that, and there are some worries, but by far, it's clear the largest source comes from burning fossil fuels. And you can do, for example, isotope analysis and see how recent the carbon in the atmosphere is. And so there's relatively little question about the source. There was more of a question with methane, because some of the methane is produced, again, more by some by rice paddy, some other by natural agricultural releases. And there, again, isotope analysis has helped a lot. But with carbon dioxide, there is such a huge amount of carbon dioxide released by burning fossil fuels that were actually put there by photosynthesis, except it took millions of years, and in just a few decades we are releasing that. So that overwhelms the other portions of the CO2 balance. Not that CO2 doesn't have other implications. For example, acidification of the oceans is yet another worry. Sea level rise. I didn't mention all the impacts, but one that it is not connected to climate, that is indeed worrisome, is this acidification of the oceans, because it's happening so fast that there's not much time for biology to adapt to this rapid change.
Yes. You mentioned the views of Stern and Weizmann.
Right.
But of course, a lot of the dispute about climate policy is caused not by differences in the views on the science, but by differences in the appropriate discount rate. And would you not agree that the Lombard consensus, for instance, comes to this conclusion that there's low priority to deal with climate change simply because they take a higher discount rate, which writes off the downsides of anything that happens beyond 2050. So it seems to me that one has to keep banging on about the obligations to future generations. As some people put it, you should not discriminate on grounds of date of birth. You should care about what happened in the lifetime of someone just born now. If you don't do that, if you apply the standard discount rate, then you will indeed think that it's more urgent to help the world's poor in other ways. But it's only if you think that in this context you should apply a low discount rate that you then feel it's worth paying a premium now in order to reduce a risk that would otherwise fall on people 100 years from now.
Sure, I agree. The interest rate is, and again, this was discussed, as you know, and there's quite a bit of economics literature to use a variable rate. But the point, in some sense, that I try to make as well is that it's not just economics. Okay, at some point, you have to talk about disruption to the way society functions because of large migrations and so on. So that's when you get to that point, you're really talking about a responsibility with future generations that goes beyond economic growth. It goes to political stability and so on. And even health effects, okay, recently they have been again sort of highlighted because we are already seeing in Asian countries thousands of people dying because of very significant heat waves. How much does that cost? What interest rate do you put in for these effects? Okay, that's more of a social responsibility or ethical issue rather than just economic considerations. Peter.
Well, two quick points. The first one is that, as you know, the current IPCC expects or projects that 20 to 30% of all species on Earth would be exterminated within this century by climate change alone. That may be too high, but it's completely intolerable, especially given the fact that we know only a little bit about a few of them, and most of them have gone without any recognition at all. The second point is an economic one. I think the arguments have to be made, as you just did. Look up the website Footprint Network if you want to realize what a fantasy it is to imagine a 400% growth in the economics of poor countries in the world. I think we have to face the fact that our current economics are flawed, depending as they are on growth in natural resources with demand. And no one who's ever studied it imagines that growth in labor with demand, but not growth in natural resources. I think the arguments are we really have no choice. A recent meeting that I convened at Washington University projected that the whole climate of the Midwestern United States would change irretrievably in the next 20 or 30 years, no matter what we do, and that's one of the major agricultural areas in the world. So let's get on with it. Let's get on with it from a point of view of saving ourselves and not dwell on economic fantasies along the way.
Yeah, I agree.
Yeah, I'm sure can continue our discussions for a long time. I'm just looking at my watch, and so I would say maybe one more question, and then we should give the word to the next speaker.
You have to turn on the microphone to your right, up there. Here's one.
Okay, Mario, you talk about 1.5 degrees or 2 degrees, and actually IPCC in 2001, in their report, especially the burning ember, if you look at it, 2 degrees centigrade rise from pre-industrial era, the large-scale sudden change still in the white color. It means 2 degrees centigrade was still okay. So that was why we said 2 degrees centigrade. But then you look at the AR4, IPCC, again, the burning amber, then you will see 2 degrees centigrade. Based on our scientific investigation, 2 degrees centigrade is miserable. The probability of sudden change is really quite huge. It's already in the orange color.
Right.
Then you look at the last report of AR5, IPCC report AR5, and again look at the burning amber. Scientific research shows 2 degrees centigrade is really miserable.
Yeah.
So it's irresponsible for us to keep on talking about 2 degrees centigrade. That was one of the reasons COP21 said we should bring it down to 1.5
Right.
degree. 1.5 degree is not really wonderful at all. And we have raised the temperature by 1 degree centigrade already.
Right.
And so that's a very sad situation. 2 degree is irresponsible for us.
Yeah, I certainly agree. That's why, as you know, the Paris Agreement, the part of the agreement was to, the 2 degrees was a sort of nominal number, but with striving to reach actually 1.5, and that's why I was part of some of these studies. What would it take? You have to take some drastic measures, but again, they would pay themselves off. The problem is political. Okay. It's not, it is irresponsible indeed, but you need to have, the United States has to participate in these negotiations, being the second largest emitter now after China, but the most important economy in the planet. So the other way to look at it, look, it doesn't matter that much whether it's 1.5 or 2 or whatever. Let's do whatever we can. Let's convince the planet that it's an urgent thing to do. And our first task is to convince many of these important decision makers that they need to do something, let alone 2 degrees or 1.5. They would, if you let them do what they want, they would remain with business as usual. Okay? So that's why we tell them that's really scary and that's highly irresponsible. And so it's not acceptable in our society to run such a high risk with future generations. But the first job, I insist, is to convince decision makers that they should worry about this. And then second stage, okay, once they accept, let's do the most we can. That's why we need better technology so that it's cheaper and you don't have to fight as much for the economic changes. But I agree certainly with you.
We now come to our next contribution. Professor Kim Tamani Rao will talk about novel strategies for energy devices based on advanced materials.